Hello, this is Algebra 1. We're going to be talking about relations, domain, and range. Well, relation is real simple. It's a set of related numbers. Okay? And relations can be expressed in four different ways. We can have a graph. We can have a set of ordered pairs. We can have a table. Or we can have a mapping. And what we're going to be doing today is they're going to give us one of these four, and we're going to translate it to the other three. So let's go ahead and have a look. In example number 1, they've given us a graph on the coordinate plane, and we need to list them as a set of ordered pairs, a table, and mapping. Well, let's do the ordered pairs first. And I always like to work left to right, so I'm going to go ahead and say this is my first point. And it is located at 1, 2, 3, 4, negative 5, 1. I'm going to go ahead and put a mark through it so I know I've got that one. Next, we have this one, which is located at 1, 2, negative 3, then down 2, negative 2. Over here, we're at negative 2, 1, 2, 3, 4, negative 5. They gave us one of the origin, that would be 0, 0. This one would be at 2, 2. This one is at 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 1, 2. And so that's a set of ordered pairs. Now, your order does not matter. You can put them in whatever order you want. Just make sure that you list all of them. Now we're going to go to our table, and we're going to list our coordinates here. Now, a table, we generally want our x values to be in order, which is why I go left to right, because that puts the x values in order. And I have negative 5, 1, that's the first point. Negative 3, negative 2, that's the second. Negative 2, negative 5, that's the third. 0, 0, 2, 2, 4, 6, and 5, 2. And so here we have a table. Real easy, just take your ordered pairs, plot them down. Now for mapping, you need to do this a little bit different way. Your x-coordinates go in the x bubble, but they only go one time. Okay, so I've got a negative 5, a negative 3, a negative 2, a 0, 2, 4, and 5. None of those repeated. Now I'm going to come over here, and I'm going to go ahead and put these in order. My negative 5 is the smallest. And then I've got a negative 2. And then I've got 0. Then I've got 1. Then I've got 2, but I've got 2 of them. I only put it in once. And then I have 6. So I've listed my x values, I've listed my y values, and now to map it, I connect points. So I need to go from negative 5 to 1, from negative 3 to negative 2, from negative 2 to negative 5, from 0 to 0, from 2 to 2, from 4 to 6, and from 5 to 2. And that's how a mapping is done. You put your numbers in order, and you only put them in once, and then you connect them. So we've got graph, set of ordered pairs, table, and mapping. Now let's go ahead and talk about some other vocabulary words. The domain is the set of all input values. That would be all of your x's. The domain in example 1, I put a nice curly brace, and then I'm just going to write everything that I find in the x bubble. -5, -3, -2, 0, 2, 4, and 5. For my range, I just put everything that's in the y bubble. It's a set of all output values, which is all of your y's. We get our curly brace, -5, -2, 0, 1, 2, and 6. Now it's very important these are in order, without repeats. Okay? No repeats. Notice my domain is larger than my range because my range has 2 show up twice. So now we've talked about relations, we've talked about domain, we've talked about range. Now we're going to talk about functions. Now function is a special type of relation. None of the first coordinates repeat. Okay? Which means all the x's are different. So now we're going to list our domains, range, and describe whether or not it's a function. So my domain, -1 is the first one, and then 2, 3, and 6. My range, well, I've got 3 as my lowest, and then 4, and then 5, and I've got another 5, but I don't repeat it. So is this a function? 2, 3, 6, -1? Yes. Let's look at our next example. For our domain, our smallest number is -4, -2, 1, that one repeats, and then 2. My range, my smallest number for my range is -3, and then 5, and then 6, and then 8, and then 9. Now, is this a function? The answer would be no, because my x values repeat. Now, if x values repeat, it's no. If the y values repeat, it doesn't matter. All we care about are the x values. Do the x values repeat? If so, it's not a function. If they're all different, then it is a function. Let's go ahead and knock out example number 4. We're given a mapping. We need to figure out our ordered pairs. Well, this would be 2, 12, 2, -3, 1, 5, 0, 0, and -1, 5. Our domain is easy. You just pull from here. 2, 1, 0, negative 1. Put a curly brace. Our range, we just come after these y values. 12, 5, 0, and negative 3. And now we wonder, is this a function? Well, that 2 has two numbers coming off of it. And if you'll notice, that 2 shows up twice over here. So no, it is not a function. Moving on. Now we're just given graphs, and we're asked to determine the domain and range. So for our domain, we just need our x values. So over here, 1, 2, 3, 4, 5, 6, 7, 8. That would be negative 8. 1, 2, 3, 4, 5. Negative 5. Negative 1. 1, 2, 3, 4. And 4, 5, 6, 7. Positive 8. My range, 1, 2, 3, 4, 5, 6, negative 7. Negative 5. 0. 2. And 5. So it's real easy when they give you those, you just go and identify your points. However, number 6, we don't have individual points. What we have is a line. So example number 5 is a version of discrete points or discrete data. And number 6, we have continuous data. And to do this, we need to figure out where our x's come from and go to. Well, our smallest x is way over here at negative 8. Our largest x is over here at a positive 2. And we know that x is in the middle. So I'm going to put less than signs. Negative 8 is less than x, which is less than 2. However, because these circles are filled in, they get little equals bars. And so that's our domain. Now we look at our range. Well, our smallest range value is 1, 2, 3, negative 4. Our largest range value would be 1. For range, y is in the middle. And again, because both of these are filled in, they get equals bars. And so that is problem number 6. Moving on to number 7. We're going to do similarly. Our domain, the smallest value, is 1, 2, 3, 4, 5, negative 6. Our largest value, 1, 2, 3, 4. X is in the middle. And now we look. This one is open. Open does not get the equals bar. This one is closed. And so it does. Our range, our smallest range value, negative 2. Our largest, 1, 2, 3, 4, 5, 6. Again, y is in the middle. Our smallest one is open, so there's no equals bar. Our largest one is closed, and so there is. Another example, smallest is negative 3, biggest is 1, 2, 3, 4, 5, x is in the middle, and since they're both open, there are no equals bars. Same thing for y, negative 1, 1, 2, 3. Both open, no equals bars. And now for number 9. Well, number 9 is a little bit different. It goes on forever. So I'm going to start this just by putting x and y and finding my coordinate. 1, 2, 3, negative 3 in x, 2 in y. And now I've got to figure out, am I going bigger or smaller? Well, my x is going to the right, and so x is greater than or equal to negative 3 because it's closed. My y, we're going down, and so it is less than or equal to. Right now for our last example, x and y, 1, 2, 3, 4, 5, negative 2. Now this time in x, I'm going to the left, and so I'm less than. It's open, so there's no bar. And y, I'm going up, and so we're greater than. It's open, so there's no bar. And so that is our beginning intro into relations, functions, domain, and range. You need to really make sure that you understand domain and range because it's going to keep on popping up throughout the year. Good luck on your assignment and have a good day.